Hi, everyone. Just wanted to take a minute to talk a little bit about exponential functions. So in this particular video, I'm just going to talk about general features and an overall kind of overview on exponential functions, where we will talk about some of the key information to look for in the graphs. So what you see graphed on the screen right now is the graph of the function f of x is equal to 2 to the x. So this is the parent function for exponential functions. Most other parent functions are something like y equals x or absolute value of x. You're probably wondering, why does this one have a 2? Well, the reason behind that just comes down to the fact that it's kind of the smallest regular looking number, almost, so to speak. It's the smallest counting number I'm going to be able to really use for an exponential function, right? Because if I had 0 and I kept raising 0 to a power, it's still just 0. And if I had 1 and I kept raising to a power, it's still just 1. So really not a lot interesting happens. But when we start getting into 2 and then 3 and 4 and so on and so forth, it gets a lot more interesting. Also, you can use decimals and whatnot as well, but we usually don't use the decimals for the parent function. So just looking at this, what are some pieces of information we are immediately getting? Well, on the right-hand side here, the first quadrant, you can see a very rapid incline, right? It's increasing really quickly. It has a very, very, very fast rate. And then over on the left-hand side here in quadrant 2, you can see it levels off. And it looks like it keeps getting closer and closer to 0. But you'll notice as I keep going and going and going and going and going, it never quite gets to 0. It gets close, right? It gets close to the x-axis, but it doesn't actually touch the x-axis, okay? That's an important feature in regards to exponential functions, all right? They have something called an asymptote at the x-axis. It means they just keep getting infinitely closer, but they never actually touch it, all right? So you could keep going forever, and if I zoom out and out, you can see I'm getting closer and closer and closer and closer and closer and closer, and I'm still getting closer and closer, and it's even rounding down at this point. But it's never crossing over, right? It is rounding, but that's just because anything beyond 3 decimal places is still 0, right? But if I plugged in a negative number like negative 100, right? It's not 0. Not 0. Not, well, okay, it says it's 0, but it's not really 0. It's too small for the program to even register. But it's still not quite 0. That's the point I'm getting at here. So it gets infinitely closer, and that is something called an asymptote. And depending on your function, your asymptote can change. Your general one with nothing added, your asymptote is always just going to be the x-axis. Okay, so it's never going to cross the x-axis. What else do we notice? When we look here, as we said, it is increasing the entire time, right? It has a general upward trend. It is increasing the whole time. The other thing I want to look at here is, let's look at the rate of change. So we notice here I have -1 and 0.5, right? And I go to 0, 1. So if I were to find the slope, or the rate of change, I should say, because it's not a slope. If I were to find the rate of change, well, what could I do? We have 0, 1, right? Here's my points. 0, 1, 1, 2. So the change in y would be 2 minus 1, 1 minus 0, right? 2 minus 1 is 1, over 1 is 1. Now let's look at the next 2 points. 1, 2, 2, 4. 4 minus 2 over 2 minus 1. I'm still only changing by 1 in the denominator, right? But now I'm changing by 2 in the numerator. And if I kept going, you'll see that these are going to be different every single time. My rate of change is not constant. It depends on which points I am plugging in. And in fact, as you get further and further along and get bigger and bigger x values, my rate of change is actually increasing. Well, it's increasing exponentially, right? So for example, if I now look at the next one, 8 minus 4 over 3 minus 2, you still have a 1 in the denominator, but now it's 4. And you can probably, 4. You can probably see where this is going, right? If it's 4 now, then what's going to happen? It's going to be 8, then it'll be 16, then it'll be 32, and so on and so on and so on. Okay, so you'll notice the rate of change is not the same. What else do we notice? When we look at this, what is my y-intercept? Well, my y-intercept is 0, 1. And what's the reason behind that? Anything to the 0 power is just going to be 1. So because 2 to the 0 is 1, 1. All right, so that will be your y-intercept. There is no x-intercept. Remember, x-axis is a asymptote, so we are not touching it. What else do we need to look at? The only other piece of information we should talk about is the domain and range. So I can plug in any x value. The domain is fine. The domain is infinity, negative infinity to infinity. All right, I can plug in any x value. But what is my range? Well, I never quite touch 0, so I don't include 0. But anything above 0, fair game. Okay, so anything above 0 is fair game. All right, so my domain is negative infinity to infinity. My range, that's a little bit trickier. It's 0 to infinity. Or you can just say it's, y is bigger than 0. I've seen that written before. But that kind of covers all the general features. And that's really going to help you if you can identify a lot of those features when you're looking at graphs. All right. The other thing I want to talk about is watch what happens if I turn this 2 and I change it. I make this a 1 over 2. Why not, right? Make it 1 over 2. All right. And what do we notice? Well, before it was increasing, and now it's decreasing, right? So now it's decreasing. Okay. My asymptote is still the x-axis. It's still not touching 0. It's getting close, but it's still not touching. My y-intercept is still 0, 1. The only thing that is different is that now in quadrant 2, I have that really far up to infinity really quickly. And then in quadrant 1, now this is where I'm getting closer and closer to 0. So that's just coming from the fact that I have 1/2 as my ratio, right? If you think about it, this is a very similar structure to what you saw with the geometric sequences, right? So now my ratio is 1/2. So it's getting smaller, 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 smaller each time. Well, what would happen if I plug a negative number in, right? If I had 1/2 to the -3, it's going to be the same as 2 to the 3rd, right? We're flipping because of the negative exponent. So that's why the left-hand side is now the one that's going way up. So ultimately, that's the only thing that has changed, though. We have now essentially just kind of, well, what did we do? Before, if we look at the other one, 2 to the x, right? So we've really just kind of like reflected it across the y-axis, right? That's all we've done. So that covers most of the general information. The only other piece of information I want to talk about is what happens if I start putting numbers in front of this, okay? Right, so as you recall, when we were looking at geometric sequences, we had the initial term. So watch what happens if I put a number in front. What if I put 3 in front? Most of the features stay the same. It's just now, what's my y-intercept? 0, 3, right? I put a 3 in front, my intercept becomes 0, 3. Okay, everything else has stayed the same pretty much. I mean, some of the values obviously have increased more significantly. The rate of change is still not constant. I still have a horizontal asymptote that it's still never 0, but my y-intercept has changed, right? So if I made this, 0.2, right? Now it's 0.2. If I made it 0.4, oops, but I've made it 7, it's up to 7. right? So the only thing that is changing from that front, again, it's kind of changing a little bit of the steepness and things like that, but really it's also changing the y-intercept, all right? The final thing is, as you would gather, if I made this negative, what's going to happen? It's going to flip over the x-axis. Okay, so now my range is -infinity to 0, but nothing else is changing. Okay, so just be careful with that. So your y-intercept is still going to be your initial value, so to speak. All right. So hopefully this covers some of the general information that you need to know about exponential functions. Going forward, we are going to look a little bit at graphing and dealing with tables of exponential functions. So hopefully that'll help clear up some additional questions if you come across them. All right, have a great day and let me know if you have any questions.